Chapter 3 is such a long chapter because it's so full of the fundamentals. If you don't get this, then later on when we start doing inserts, updates, indexes, things are going to be so difficult for you. So slow down. Don't be in a hurry to get through this chapter. I know I'm doing some 20-minute videos and this is, maybe longer than what you expected, but you can't skip the fundamentals. They are the fundamentals. I've never met an expert that didn't also know the fundamentals. So let's continue here with our final type of constraint, the foreign key. Now the foreign key is probably the one, how can I say this? The one where people will get confused on the most. Like, I think it's fairly easy to understand the unique constraint. The unique constraint is an alternative to the primary key. Okay, how many primary keys can you have on a table? One. There's only one way to uniquely address a row. Okay, that's the whole purpose of the primary key. But a unique constraint, we can have several unique constraints on a table. There is a slight difference between a primary key and a unique constraint that we did not mention in the last video, but I should have. A primary key cannot have a nullable column. A unique constraint can, but can only have a single null value. I'll reiterate that. Primary keys cannot have nullable columns. They're built on non-nullable columns. That's one of the rules. Unique constraints can be built on top of nullable columns. However, there can only be one null value present, or one combination of each null. All right, okay, so back to foreign keys. Check constraints are easy because it's a custom business rule. I want employees who are 21 years or older. I want all products in the order details table to have a unit price of 0 or greater. That's a fairly logical thing. Oh, I need to put a filter in that says you can't put anything below 0 in here. Foreign keys, we're starting to talk about parent and child relationships. Okay? Now this is where it gets into the mental aspect of it, and some people just, for whatever reason, have a difficult time with this. Okay? What I'm going to do is do this in code, and if I feel the need to start drawing, I will. We have our business rule. Hold on, before we get into the business rule. Remember that we have the member, but we can't tell Scott Wiggum what his password hint was. Remember, we're modeling this based on a website registration form. That's what we're storing. Some of the information is coming from here. So when we registered Scott, we offered him a selection of different password hints. What's your favorite? Which one do you want? What's your favorite pet? What's your favorite color, etc. And this is in the event Scott forgets his password. He can just recover the password all by himself without us having to intervene. But it's not stored here. So where is it stored? Well, in this model, and there's different models we could have chose from, but in this model, let's say this, business rule, a user should be able to recover their password if they successfully answer their chosen password hint question. Okay. Here's the business rule. Each user can have only one password hint question. Now, I've been to sites, and so have you, where at one time I would be presented with one question. The next time I log in, I'm given another question. Next time I log in, I'm given a different question. Okay? Well, in this case, we don't have that. The user is given one single question, and when they sign up, they're asked that question. They provide an answer. They lose their password. They can recover that password automatically by providing the correct answer. Okay? Now, to do that, to implement, add a column to the member table to store password hint answer, will that solve it? Okay, I'm probably being a little pedantic here, and you probably already get the whole idea, but just to make sure some folks may not, we're going to add a new column, password hint answer. We're going to allow it to be in Unicode, in varchar, so it can be Unicode, 128 characters. It is a required column. Okay. Now we're going to have a failure because we actually have a row of data. And if we add a new column and say it's not null, then what would go into that row? Nothing. So we will actually get an error message. Okay? So we have to then first update member to, first, if you remember, we went through this. We have to mark it as null, update it to set password hint answer equal to a value equal to fluffy, for everybody. That way it has a real value. And now we have to modify the column, okay, to where now it is not null. If what I just went through to add a new non-nullable column was kind of fast, we went through this in, I want to say, video number 15 and 16 in this chapter already, so you might want to go back and look at those. Okay? So I'll go and execute these. We now have a non-nullable column called password hint answer. Okay? And sure enough, Scott's password hint answer is fluffy. What's the problem with this design? Which password hint? What question is this the answer to? We don't know, do we? That's the problem, right? So we add a column to store the password hint answer. We also add a column that tells us which password hint that the user chose. Right? That way we know that fluffy is the answer to the pets, or fluffly, I guess is what I typed in. Okay? So it's the exact same thing. So let's just go through this same thing. So we'll say add password hint answer. And now let's come down and add password hint ID. So password hint ID. Now password hint ID. What's the data type? Let's go back. This is going to be a reference to this column, right? So we're going to store the hint ID. So it needs to be car5 over here. I got a lot to talk about here with you, so just stick with me. Okay. Now we're going to add the password hint ID. We're going to assign it to be a value. Let's make it pets. No, I'll make it, yeah, we'll make it pets. I got so much to talk about. It's hard to just pick like one thing. So then I mark it as being a not null column. So when we refresh at the columns level, you could see that it now is set up here. Okay, so now we could actually start implementing a password reset program. The user, Scott Wiggum, comes to the website, can't remember his password, and so he puts in his address. We then ask him the pets question, and if he provides the correct answer of fluffy, then we'll either reset his password by providing a new password and updating this one, or sending him this password in an email. You know, that implementation details for later on in the course here, okay? But we need to know what that question is. This is a child, okay? Now the last implementation here bit is set up a foreign key where dbo.passwordHint is the parent. Get my constraint. Come down here. There's so much here I'm going to talk to you about. Okay. DBO.member. This is the child. Okay. You are altering the child in the relationship. Okay. Add the constraint fk underscore member underscore password hint. And my convention is fk underscore child table name underscore parent table name. That way, if I get a constraint error, I can look at it and say, oh, well, I know what the problem is. I'm at the child, and there you go. What's the constraint type? Okay, foreign key. Which column or columns is this built on? Okay. So you are specifying the child columns. The columns from the child table. References dbo.password hint ID. Parent table name, parent column names. Okay, this is big. Alter the child. We're adding a foreign key. We're saying that the password hint ID column is a child to the hint ID column. Notice that they don't have to be the same name. It's not even the name of the column that has anything to do with the foreign key. Some people think that had we just made this hint ID, it would automatically be a foreign key. No, that's silly. No way, man. However, the data types must be identical. So column names in a relationship, that's what this is called, a foreign key relationship, can be different. But data types must be identical. Okay, so we had to both be using car 5. We couldn't have a car 6 and a car 4, a car 6 and a car 128. The nullability can be different. Okay, now, final little bit of rule here. The parent column or columns must be in either a primary key or unique constraint. Okay, you are defining a one-to-many relationship. One parent begets many children. Okay. Pets, for example. We're looking at the child table right here. We're looking at dbo.member. There could be 10,000 members that have this same password hint ID. But when we go to that parent table, how many rows have a hint ID of pets? 1. It's a one-to-many relationship. One parent can have many children. One child can only have one parent. Okay. All right, so let's go ahead and add this in. Does it affect the table? Have we changed the values, the data in the table? No. This was successful because pets already existed. Okay. Pets already existed where, Scott? I don't get it. What are you saying? Hold on, let me come down here. I've got too much. I don't like all this scrolling. Select member ID, email address, password, hint ID from that. Okay. Just kind of keeps it sort of tighter. And just a little trick for you. Remember the red squiggly? It hasn't refreshed the cache. So go up here to edit IntelliSense, refresh the local cache, and there, it picks it up, and that goes away. Now let's select all from password hint. And you can see there is a pets. So now we know when Scott at yahoo.com comes to the website and says, I need to refresh my password. I need to reset it rather. we know to provide him with the password hint, what is your pet name? And then we go to Scott's user account. I guess I should provide his password hint answer. And we know that if the question that he answers does not evaluate the fluffly, that we don't reset it. But if it does show up for pets as fluffly, we will reset his password. Okay? Password hint is the parent. DBO.member is the child. Okay? Now watch this. So foreign keys prevent orphaned child records. Watch this. Let's try to delete password hint where hint ID equals color. Now let me ask you this. How many children does color have right now? How many records in its child table member have a password hint ID of color? 0, right? We have a parent with no children, so it's not even a parent. Huh? So will it delete successfully? Yes. So success, no children. Now, can we delete pets? The whole purpose of the foreign key is to prevent orphaned child records, and it will not allow it. Okay? Not saying it explicitly, but it's telling you right here the delete statement is not working because the column at the child table has at least one row with this value. You would end up with an orphaned child record. If we were allowed to remove this parent, then we would have an orphaned child record, and the foreign key does not allow that. Okay? Prevents it. That's the whole point. Now the same thing goes with updates. So fails. How about this? Set, let's look at the hints again. Team. Set display text equal what is your favorite football team? Where hint ID equals team. Will the foreign key be invoked at all? No, because we're not changing what the foreign key is built on. We're just simply using the primary key as a lookup, but we're changing a column that is not at all involved in the foreign key. Okay? Now, if though we come down here and say update dbo.password hint, set hint ID equal teams, team F for football, I don't know, or F team, where hint ID equals team, will the foreign key now be checked? Yes. Yes, it will. And here's the question. Will running this update statement cause any orphaned child records? No. There are no records in the child table that reference team. Look at this one though. Update password hint, set hint ID equal pet, where hint ID equal pets. Okay. Will the foreign key be invoked? Yes, because we have the foreign key column in the set clause. We're changing the value of the foreign key column. Would doing so cause any orphaned child records? In other words, are there any child records that currently have a hint ID of pets? Yes! So this will not work. The update statement fails because you're going to have orphaned child records. You would have now, let me come back up here. I need to put this down here. you would end up having a situation where you have a password hint ID of pets, but now you have password hint of pet. And that would not match. You would no longer have a parent. You'd have an orphaned child record. Okay? So the whole point, the purpose of foreign keys is to prevent orphaned child records. Okay. Now that we've said that, final thing is you can deal with, you can perform, gosh, how can I say this? I can say, let's come back in the next video and do this.